still has to go through.
Yeah, you gotta get those perfect, like.
I already have like a whole set.
All right, so let's finish this example from yesterday. Bless you. Okay, before we even get started, maybe we should just expand it, right?
Yes.
So let's expand it. So what do you want to do first? X plus 1 squared?
Yes.
What's the shortcut for that?
S
S mas. What does that mean? X squared plus 2x plus what? 1. And we have all that times 2x minus 1, right? Here we go. 2x times x squared. 2x cubed, right? 2x times 2x.
4x squared.
2x times 1. 2x, right? Now the other one. Negative 1 times x squared. Negative 1 times 2. Negative 1 times 1. What can we combine? So we got the 2x cubed plus what? 3x squared. The 2x's go away and we're left with minus 1. Is this the derivative? No, this is just the what? The same exact function up there, just rewritten, yeah? With me, Ashley?
Yes.
Yes? Okay, make sure you look up here. Alright, so now we can get the derivative. So f prime of x, what would it be? 6x squared plus 6x.
6x.
Why did I need that? Why did I want the derivative? So I can get the slope at this particular value, right? Okay, so now we're ready to work with the equation. So I need the point of tangency, right? How would I get that one? Plug into the original function, right? Okay, so which one do you want to use? Do you want to use the one that we simplified here or the very first one? The very first one? The first one? Whatever? Doesn't matter? Okay, well let's use this one. What's negative 1 to the third? Negative 1 times 2? Negative 2. Negative 1 squared? Times 3? Minus 1. So what does that give you? 0. Very good. Okay. So my point of tangency is negative 1 comma 0. Good? Alright, what else do we need to find? Slope of the tangent line, right? So let's find that slope of the tangent line. We're going to use now f prime of what? Negative 1. So now which formula do I use? The derivative, right? So that'll be 6 times negative 1 squared plus 6 times negative 1. What does that give us? 0?
0.
Yeah, 0. Okay. So what's my equation of my tangent line? Y minus 0 equals 0 times x plus 1. So 0 times anything is what? 0, and if we add 0 to 0, what do we get? So that really is just y equals what? 0, which is the same as what axis? Very good. So the tangent line would actually end up being where? The x-axis at what particular value? At what?
Negative 1.
At negative 1. Do you want me to draw it for you so you can see that tangent line? Yes? No? Don't really care? It's okay? Doesn't matter to have a graphical view? I'm going to do it anyway.
You already do it.
What?
Do you see it? Oh, it's gone now.
What?
The little toe.
Yeah, the light from the.
Oh yeah, on the thing?
Yeah, the little toes.
The little ghost that always hanging out there. So, they wanted the slope of the tangent line at what? Negative 1. So what's happening there at negative 1? It's a relative maximum, right? So we ended up with a what kind of tangent line? horizontal tangent line, right? So we know that when we have a horizontal tangent line, we know that we should have a maximum or a minimum, and we also know that the derivative at that point should equal to what? To 0, and that's exactly what happened. Cool? All right. We're good? Ready to move on? Let's do it. Here we go. So let's do some trig, a little bit of baby trig here. Sine and cosine. Okay? So let's look at this guy. And what I want to do is I want to get started on the derivative. And then you're going to find out that as we get started on it, we're going to need to know something in order to continue to find it. Okay? So remember, if all else fails, we always have Old Faithful. Right? Who's Old Faithful? What is this called? We always have the definition of the derivative. So if I forget all those rules that I'm going to show you, which I hope you won't because we're going to use them so many times, we can always go back to Old Faithful and use it to find what? I can use it to find the derivative. If I ever wanted to go back. Okay? And we're actually going to use it today to find the derivatives of these two trig functions, alright? So let's get it started, alright? So we need to find the limit as h approaches 0 of what? F of x plus h. So what would that give me if I put x plus h there? Sine of x plus h minus f of x, which is just all over h. Okay? So what do I get if I plug in 0? Sine of x, right?
Yes.
Minus sine of x. That's what? 0 divided by? Oh, so it was 0 over 0, so what does that mean? Means it can be fixed, means that there is a limit, right? Okay, and whatever I get should be represent my derivative. So how do I fix this problem? Use the conjugate, do you think that will help? Like sine of x plus h minus sine of, plus sine of x? No? That won't help. What I actually need to know in order to continue this problem is how to expand this right here. Okay? So some of you in your pre-calc classes, you went like hardcore into trig formulas and trig identities and all that. So maybe you might know. Don't rip my tape off, please.
Just a little piece, and it
Okay.
was like, it looks fine now.
Yes.
Oh,
So we're going to go over those two particular formulas that you would need to expand that, right? Just for now, not necessarily do you need it for the entire calculus class, or you're going to have to recall that particular formula, all right? To be successful in this class, you don't need to know all of those particular trig identities, okay? But they're actually up here. So they are called the sum and difference formulas. Any of you remember seeing these ever? You remember hearing of it? I'm sure some of you did that, depending on what class you were in. Okay? So I'm going to give you both formulas, okay? So if it were cosine of A plus or minus B, add the minus, and also sine of A plus or minus B. So right now we need the one for what? For sine, but when we do this one, what are we going to need the one for? Cosine, because we're going to have cosine of x plus h. So do you see it? A plus B? Good? Alright, so here we go. I'm going to write both of them for you. For the top one, it's really easy. It'll be cosine of the first term A, cosine of the second term B. So it's cosine, cosine, AB. Easy? The tricky part to remember here is that when it's a plus over here, it's actually a minus here. And when it's a minus here, it's a plus in the expansion. That's why I wrote it backwards, okay? If it's a plus, it's a minus. If it's a minus here, we put a plus. Got it? And then on the other side, all it is sine of A times sine of B. Pretty good? Cosine, cosine, sine, sine, AB, AB. Easy? Remember to flip the sign depending on what it is. Now the other one, this one's a little bit interesting. So this one will be sine, cosine, yes? Plus or minus, this one doesn't switch. And then this one will be sine, cosine. Right? The first two go directly, so this will be A and this will be B, and the other one they swap. So now this one's B and this one is A. Yeah, if it's plus, it's plus. If it's minus, it's minus. Good? Any of you recall using this? Yes? Maybe? Alright, so what we're going to do is we're going to use those expansion formulas to expand this right here. So let's expand sine of x plus h. That would be this one, right? So what am I going to write? Sine of x cosine of h. Plus or minus? Plus. Sine of the second letter h cosine of the first letter.
But it's x plus h.
Right, x plus h. We're using sine, right?
Yeah.
So it's plus. Yes, we're not doing cosine of x plus h. We're doing sine of x plus h. Yes?
Yes.
Okay. And then it'll be all of that, that's just this part right here. Minus what?
Oh.
Sine of x. All divided by what? By h. And I want the limit as h approaches 0. Orale, how did that help me? What do you think we could do to it now?
You can take out a sin x.
We can take out a sine x. Not all of them have a sine x.
Cancel on.
But I like the way you're thinking. Can I take out sine of x out of two of them? Yes? So I'm going to put those two together so I can take the sine of x out of those two. So check this out. We're going to have sine of x cosine of h. Bring this guy to the middle. Minus sine of x plus sine of h cosine of x. Is that a legal move? Can I just put him in the middle if I wanted to?
Yes.
Yes, because it's addition, right? So now between just those first two terms, what do they have in common? A sine of x, right? So let's take that guy out, just out of those two, and you're going to see what's going to happen. So we're going to take out a sine of x, and now I have cosine of h minus what? 1. And then plus sine of h cosine of x. Does that kind of look familiar? What does that kind of look like? They were like shortcuts. We did it a while back. Yeah? Does it equal 0? One of them equals 0 and the other one equaled what? 1. Hard part is remembering which one's which. This one's 0? The one that looks like this one is 0, but not this one. What was the one for sine? Sine of x over x, or x over sine of x, right? That one was equal to 1 when you're getting the limit as we approach 0. For this one, it was actually the reverse of this. It was actually 1 minus cosine of x over x. Could I make it become 1 minus cosine of x? How could I do that?
Factor out a negative.
Take out a negative. Okay, cool. So let's do that. So now I have negative sine of x times cosine of h. Whoa, 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 whoa. 1 minus cosine of h, right? And could I split the fractions? Could I say all of this divided by h plus sine of h cosine of x divided by h? Is that okay? Not equal, sorry, the limit as x approaches 0? Or did I lose you by splitting it up right there? Okay? Okay, so now if we look at it, we're, oh, not x, just kidding. H approaches 0. So as h approaches 0, we think about the limit right here, what would this particular part give me? So that would give me 0 times negative sine of x. And what would this one give me over here? Is that another one? Oh, that's the other one, right? So that would be plus 1 times cosine of x. So what's sine times 0? So that's 0 plus 1 times cosine? That means that the derivative should equal to what? Cosine of x.
So with sine of x, you end up with cosine of x.
I don't know. With sine of x, we did get cosine. Yeah, that's the one we just did. Right? So the derivative of sine, we know should quickly just be what? Cosine of x. But we know how we got it now, right? Yes? Could I have very quickly just told you that? Alright guys, you need to memorize, alright? The derivative of sine is cosine.
Yeah.
Woo, we're good. You would have been happy with that?